Good morning. Thank you for joining me today for our Zoom meeting. I would like to go briefly what we covered this week. We started talking about measuring site work and excavation. So far, we learned many information that most of the required information regarding your excavation, regarding the soil, earthwork, all of this stuff will be found in the soil report. So in the bid document, you have to look for the soil report that will tell you everything you need about the soil. And we discussed what are or what is the different type of information that you can find in the soil report. The most important thing we learned in this module that if you have a hole in the ground, like swimming pool, like foundation, like basement, whatever, and you have the dimensions for this hole or this excavation, these dimensions will give you the volume of the actual soil in the bank state or bank condition. We have three principal conditions for your soil or states. Once the excavator start to excavate, this soil will be loose, in a loose condition or loose state. And I believe the volume based on the given dimensions will be bigger when it became in the loose condition. Also, if you have a compactor and this compactor will try to compact your soil, the volume will start to reduce one more time. And I told you that, and keep this information in your mind. Any soil, whatever the type of soil, we have three components. The first one called solid particles. The second one is water in this soil, and the third one is the void. If you would like to change the volume of this soil, we will work or we will change the void volume or water volume. So if you reduced the void, the total volume of the soil will be reduced when you are doing compaction. If you increase the void, the total volume of the soil will increase when you are excavating a soil and convert it to the loose condition. And we learned also that if you would like to convert from bank condition to loose condition, this one will be called bank cubic yard. This one will be called the loose cubic yard. We need to multiply the bank cubic yard by 1 plus swell factor. We have another state which is called compacted cubic yard. If you would like to convert your bank to compacted cubic yard, you have to multiply by 1 minus shrink factor. So keep in your mind, we don't have a direct relationship between the loose cubic yard to compacted. We need to start with bank, the natural state, the original state. And we talked about this example, and we have some rules when you are trying to measure your excavation, backfill, earthwork. We have some rules. One of them, we need to make classifications, different categories for the work you are going to do. Not just the soil relation, but you need to combine all of them in one category. No. If you are doing a site clearing, you have to consider this in a different category. Excavation over the oversight to reduce level, it's one category. Basement excavation, one category. If you have the foundation excavation, it's a different category, you know. So every activity related to soil must be considered different category, the different category. Also, if you have hand excavation, it will be a different scenario because we have workers, we don't have equipment. One of the technique that we started last meeting is a method called grid method. This method will help you to figure out how much soil you need to excavate or how much soil you need to fill over the whole area of your site. This method is called the grid method. I would like to remind you what we learned last meeting regarding this method. We have area of land, and the soil surface is not flat. The soil surface looks like this, And we would like to grade this surface of the soil or the ground to a flat surface, something like this. So looks like in one part of this area of land, like this part, we are going to excavate. Sometimes at this area of the site, we will do fill. At this area, we will do fill. At this area, we are going to do cut or excavation. So the final conclusion, your surface will be flat. How to consider this in your calculation? We have a technique. The first step in this technique, we are going to divide this area of land to a grid with equal spacing. Prefer to be equal spacing. Every 100 feet, every 50 feet, every 20 feet, every 10 feet, it's up to you. It's up to you, but we recommend to be equal spacing in this direction and this direction. Then you are going to use a total station or telescope, and you will ask a surveyor to come to your site, and this surveyor with his or her equipment will start to measure what is the elevation at each corner of your cells. I will consider this square or this rectangle called cell. And I can label them cell number 1, number 2, number 3, number 4, and so on. So the surveyor will tell you, the surveyor will tell you what is the elevation at each corner. And I will repeat this process at each corner of your cells. So the final answer, something like this. The surveyor will tell you what is the elevation of this corner, what is the elevation of this corner, what is the elevation of this corner, and this one, and so on. Does that make sense? Then so the elevation of this point, for example, 95. The elevation of this point, for example, 85. The elevation of this point, for example, 92. The elevation of this point, for example, 84. The elevation of this point, for example, 96, and so on. I need to excavate or to grade this surface to a grade level equal, for example, 90. That means if the readed elevation is 95, which is greater than the intended surface elevation, that means I need to do cut. I need to remove this soil until you reach to 90. If the elevation, the readed one, by the surveyor is 85, which is smaller than the required or the intended elevation, that means I need to fill soil until you reach to the required elevation. Does that make sense? Okay. So what should I do here? I will repeat this example, but in a different scenario. I would like to grade this area of land to elevation 90 feet. So you have two options. I will follow a different option that I covered last meeting. I will put these values, which is coming from the surveyor, which is coming from the total station record, on Excel. Actually, the surveyor will provide this information to you as cost estimator as Excel data. Let's try. So this is cell number 1, number 2, number 3, number 4, number 5, number 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and 18. I will write all of this information on the Excel sheet. So this is the cell number. I have 1, 2, 3, 4. You can highlight these. And go down until you reach to 18. Like this. If you would like to make them and the middle, you can choose from this center your content to make them at the center for the cell as well, like this. If you would like to make this text bigger, you can increase the text size from here. If you would like to change the font, you can change the font from here. I do prefer Time New Roman. And if you would like to highlight, you can change the highlight of this one for any color you want. Does that make sense? So you have different options. This is related to Excel. And I will give you the record elevation 1, elevation reading 2, elevation reading 3, and elevation reading 4. This data should be coming from the surveyor. 87.6, 88.5 for the first cell. I will move like clockwise. So 87.6, 87.6 for this one. It will be 88.5, 88.5 for this one, 88.6 and 87.6, 88.6 and then 87.6. This is for the first cell. The second cell, it will be the same. I will rotate like this. So 88.5, 89.3, 88.5, 89.3, and we have 89.4, 88.6, 89.4, and then 88.6, and so on. I will do one more for the third cell, 89.3, 89.3, 90.3, and we have 90.4, 89.4, 90.4, and 89.4. Let's do one more. Let's do one more. For cell number 4, 90.3, 91.5, 90.3, 91, I think 0.5, 91.6, 91.6 and 90.4, I think. 90.4, yes. And we should do the same for all of the cells. Actually, this record should come from the surveyor. Will give you the elevation of each corner. I would like to grade this surface to 90. So the required elevation that I would like to reach is 90. Okay, so I will write here my calculation. H1, H2, H3, H4. I will write equal. So I need to do, for example, at this corner, the elevation is 87 point something. I would like to reach to elevation 90. So I need to do fill or cut. What do you think? Do you think I need to do excavation or I need to add soil to reach to the required elevation? What do you think?
You need to add soil.
Add soil. So I need to do fill. So I will start to subtract this number minus this number. Since this number will be constant all the time, 90, so I will write here $sign and another $sign before the column name and the row number, because I don't like this number to be changed to any different number. So go ahead and use only this value in this cell. So I put the $sign and $sign before D and before 3. That means this cell will not be changed 90 all the time. I will have negative. Negative means filling. So I'm assuming if you have negative value, that means it will be fill. You are going to fill soil. If you have positive value, that means I'm gonna to do excavation, cut. Keep going. If you highlight this cell one more time, and at this corner, you can grab your value, you will see something like this. Looks like all of these corners, I need to do fill. That makes sense. If you look to this cell, at each corner, all of them 87.6, 88.5, 88.6, 87.6, all of them below 90. So it looks like I need to add soil over this area. Does that make sense? Keep going. If you highlight these cells, all of them, and you can grab from here down, you can repeat this calculation for all of the other cells. If you have more, you can grab them to the end. That makes sense, but we don't have time to fill all of them. Looks like we have cell number 1, we need to do fill for all of them. Cell number 2 looks like we are going to do fill for all of them. For cell number 3, there is part we need to do fill, and the other parts we need to do cut. Something in between. But for cell number 4, we need to do cut or excavation for the whole area of this cell. Anyway, I don't care. Let's do what is the volume of each cell. I told you last meeting, the volume of each cell will equal H1 plus H2 plus H3 plus H4 for each cell, divide 4. What is the average? And multiply the average by the area of cell. This example, the length here for this cell is 50 feet, and the length here is 50 feet. That makes sense? So I will multiply. First, before you multiply, I will do equal. I will get the average. So I will write AVER. So I will have this function average. And I will highlight these numbers for H1, H2, H3, H4, and close the bracket. That means Excel will help you to figure out what is the average of these heights. Then I will multiply the value or the result by the area, which is 50 by 50. This is the area of the one cell. The final answer, if you multiply, if you get the average times the area of the cells, the final answer will be in cubic feet. If you would like to convert it to cubic yard, I need to divide by 27. So in one calculation, only one, I need to divide here by 27. Enter. That means in the first cell, I need to do fill or cut. Anybody can tell me this amount is bank cubic yard. This one or this number 178.2 will be adding soil filling or removing soil cutting. What do you think?
You need to fill soil.
Go back.
Add.
Go back. I assumed if you have negative value, that means you are filling. Why? Because if you subtract 87 minus 90 will give you a negative number. Negative number means I need to add soil to reach to 90. So if you got negative value for your volume of soil, that means I need to add soil. I need to add soil at this area. Go back to this cell and hold this corner and go down, go down, go down, and keep going until you finish all of them. You can get the volume for each, the volume of soil needed for each cell. Bank cubic yard, bank cubic yard, bank cubic yard. If you have the full data for the whole area of your land, I will have a complete column here telling you what is the volume of soil needed for each cell. One of them may be positive, one of them may be negative. The positive means I need to excavate soil. The negative means I need to add soil. By the end, I need to tell me what is the total volume of soil needed. I will say equal. I have function called the sum, SUM, open your bracket. I will highlight all of these numbers in this column, all of them, if you have all of them. Then close the bracket and then enter will give you what is the final volume of soil needed, bank cubic yard. To give you a hint, if this number is negative, I need to if this number is negative, I need to buy soil. I need to call someone to buy soil because I need to fill. Because the amount is negative, the total amount for the whole cells are negative. So the final conclusion looks like I have shortage in soil. I need to fill. If the final value for the total is positive, that means I will have extra soil needed to be removed from the site. That makes sense? Okay. This is how to figure out the earthwork for your ground area if you have this problem. I believe the biggest issue, if you are a contractor, the biggest issue is the surveyor activity, how to measure the elevation, because first you need to divide your area to a grid, and then you need to measure the elevation for each corner. Then you can set up this Excel sheet and figure out first, go ahead and put your record for the elevation at each corner of each cell. Then what is the intended elevation? Then I can figure out the required height that you need to excavate or that you need to fill. Then I can set up the equation for your volume. This equation or this calculation for the volume of each cell equal the average height. Average means this one plus this one plus this one plus this one divide 4, or Excel can do it using a function called average. Time the area of each cell, and I divided it by 27 to convert from cubic feet to cubic yard. And keep in your mind, since you are using actual dimension, actual elevation of the ground surface, that means the volume that you are calculating will be bank cubic yard, natural soil, without anything, natural soil. Then I can convert this natural soil or bank cubic yard to loose cubic yard or compacted cubic yard. Anybody has any question about this problem so far? We have another problem, which is a little simple. Calculate the average depth and the volume of excavation in bank measurement, bank cubic yard, required for the basement shown in the figure. The shown excavation depths are in feet. At this corner, the area of the land is divided to 3 cells. 1, 2, 3. If you have very small number of cells like this, no need for the Excel. Excel is used if you have many cells in your area. And keep in your mind, the smaller cell, the more accurate calculation. The more accurate calculation. But the more work you need to do, because you have to measure the elevation at many joints. If you have a smaller cells like this, so you need to measure elevation here, elevation here, elevation here, elevation here. So it's a lot of work and a long time. Anyway, so the height is already given. This is not the elevation. This is the difference between the actual height as the actual elevation and the intended elevation. So I will start directly to figure out what is the volume of the first cell. First cell, we have 4 heights. I will add them together, 8.2 plus 7.6 plus 6.9 plus 7.6 divide 4. This is the function average that Excel did it for you. The average, Excel can get you the average for these numbers using this function average. So right now I'm doing my handy calculation. Time. What is the area of this cell? This cell is divided by 25 feet and 22.5 feet. Keep in mind this total length is 45, so the mid distance will be 22.5. So the area will be 25 times 22.5. Keep in your mind, this calculation will give you the volume of the soil in cubic feet. If you would like to convert it to cubic yard, I will divide it by 27. If you look to this calculation, this is exactly what I did here. I get the average, I multiplied the average by the area of one cell and divided it by 27. So if you are using your calculator, I can give you the number 8.2 plus 7.6 plus 6.9 plus 7.6 divide 4 times 25 times 22.5 divided by 27. I got 157.8 bank cubic yard. I need to do the same for cell number 2. Like we did here, we have volume for cell number 1, we have volume for cell number 2, we have volume for cell number 3, and so on. So for volume number 2, for cell number 2, I have average 7.6 plus 6.6 plus 6 plus 6.9 divided 4 time the area 25 times 22.5 divided by 27. So 7.6 plus 6.6 plus 6.9 plus 6 divided by 4 times 25 times 22.5 divided 27. I got 141.1 bank cubic yard. Cell number 3, 7.6, 6.9. Volume number 3 equal the average 7.6 plus 6.9 plus 6.8 plus 7.4 divide 4 times 25 times 22.5. This is the area divided by 27. I can tell you the volume 7.6 plus 6.9 plus 6.8 plus 7.4 divided by 4 times 25 times 22.5 divided by 27. I got 149.5 bank cubic yard. We don't have more cells. We have only 3, so I am done. So the total volume required to be excavated, volume of cell number 1, volume of cell number 2, volume of cell number 3. So I need to add 157.8 plus 141.1 plus 149.5. Can tell you what is the total bank cubic yard to be excavated. 157.8, 141.1, 149.5. So the total will be 448.4. This is the actual. This point is very important. Everybody, please pay attention. This is the actual volume of soil that needed to be excavated. Because this number based on calculations on the actual dimensions of your area of land. That makes sense? If some information is given like a swell factor equal, for example, 12%. So after excavation, this volume of soil will not be 448.8. This volume of soil after excavation will be 448.4 times 1 plus 0.12. That makes sense? So after excavation, this number will be 502.2, and this time will be loose cubic yard. So if you are working on trucks that will remove the soil from the site to a different location, the trucks will use this number to be removed. Does that make sense? So keep in your mind, based on your calculation, the final volume is bank cubic yard. This is based on the actual dimensions of your excavation. But after excavation, after the soil is excavated, the produced soil will not be 448. It will be 502.2 after some swell will happen. Any question regarding this example? We have another example. We need to build up this house. This is the final area of your house, 32 feet by 36 feet. But if you would like to excavate for basement or for foundation or whatever, we will not excavate the area 32 by 36. We will make it wider and bigger. Does that make sense? Bigger to build your house, and then we can make fill in the remaining volume. So we are given another sketch helping you. This is what I said at the beginning of this semester. We are giving bid documents in a form of drawing and specifications. So based on the given drawings, I have this drawing that's showing up the dimensions of your house, and I have another sketch or another drawing that's showing up the cross section of your excavation. Looks like the 32, which is the actual width of your house, will be extended by 18-inch workspace. And then I will do slope of your excavation like this, one by one. What is the meaning of one by one? I mean, if you move horizontally one, I have to move vertically one until you reach to the ground surface. So this is the volume that needed to be excavated in this direction and also in this direction. I will try to help you to draw maybe 3D. I need to it's hard to me, yeah, to draw 3D, but this is the bottom and this is the top. Can you imagine, everybody? So this is the lower level and this is the ground surface. I hope you can imagine. This is the bottom level, the level of the excavation, and this is the ground surface. That makes sense? So actually, your house will be built only here. 32 feet by 36 feet. But I left 18-inch from each side. 18-inch. 18-inch. And then I started to do my slope until I'm reaching to the ground surface. Does that make sense? Hopefully you can imagine how this, you should be aware what is happening in the real life. So if you would like to figure out the total volume in a very simple way, it's easy. We are given also more information here that at this corner, we need to excavate 5 and 6 feet, 5 feet and 6 inch, I'm sorry. So this one looks like 5.5 feet. Please don't use two different units, feet and inch. So convert it to one decimal number. 5 feet and 2 inch, this one, it will be converted to 5.17 feet. This one will be 5.33 feet. This one will be 5.67 feet. So the average height that you need to excavate will equal, the average height for this area will equal 5.5 plus 5.17 plus 5.33 plus 5.67 divided by 4. This is the average height. So I need to add these numbers together. Divide 4, your number will be 5.4 feet. I need to get the average area. Average area, because we have area at the bottom. This one. We have area at the bottom, and we have area at the top. Let's try to figure out what is the area at the bottom. Anybody can tell me what is the area at the bottom? It will be 32 feet plus 18 inch plus 18 inch time 36 feet plus 18 inch plus 18 inch. Do you agree? This is the area at the bottom of your excavation. Keep in your mind this width from here to here. It's not the width of your building only 32. It's the 32 plus 18 inch from this side and the 18 inch from the other side. And also for the 36 in this direction, I have to leave 18 from this side and the 18 from this side. So 18, by the way, is 1.5 feet. 1.5 feet. 1.5 feet. 1.5 feet. 1.5 feet. So the area at the bottom will be 35 feet by 39 feet. Does that make sense? 1,365 square feet. What is the area at the top? What is the area at the top? Keep in your mind. Keep in your mind. This is a good point. So far, we decided that at the bottom, this length equal 35 feet. I will excavate average depth 5.4. So if you move vertically 5.4 average height, I have to move horizontally 5.4 also, because the slope is 1:1. 1:1 means any distance vertically must be the same horizontally. So I need to add 5.4 feet from this side and the 5.4 feet from the other side to reach to the top here and the top here. So the bottom area will be 35 feet plus 5.4 plus 5.4 feet time 39 plus 5.4 plus 5.4. Keep in your mind, we are adding 5.4 from this side and the 5.4 from the other side also. So the bottom dimensions of the excavation, we need to add this length 5.4 and the 5.4. That makes sense? So this area will be 5.4 is 10.8, so 45.8 feet time. This one will be 49.8 feet. So the area at the top will be 2,280.8 square feet. I need the average, area average. As you know, I will use the average area in between. The average area in between will be this one plus this one divided 2. The bottom area, 1,365 plus the top area divided 2. So the average area will be 1,822.9. Go back here. Your area average is 1,822.9. So your volume that needed to be excavated will be this height which is average, times this area, which is average, will give you the total volume in cubic feet. 9,843.7 cubic feet. If you divided this number by 27, I can convert it 364.6 bank cubic yard. Why it's a bank cubic yard? Because we are using the actual dimensions. Everything is the actual natural soil. So the total volume we need to excavate for this house will be this number 364.5 bank cubic yard. After, if the swell factor is given, for example, if the swell factor is given based on the soil report equal 15%, for example, so after excavation, the produced soil will not be 364, it will be bigger, 364.5 times 1 plus 0.15. So if you multiply this one by 1.15, it will be 419.3 blues cubic yard. So please rent your trucks to remove this soil based on the 419.3 loose cubic yard. That makes sense?
Did you do the 1,822 divided by 27?
This one?
Yeah.
Okay, let me, oh, looks like I have a mistake. Oh my goodness. Thank you. If you divide this number by 27, I'm not sure how I get this number. It's weird. This number is 67.5. Is it correct?
Yes.
Thank you. Thank you for the correction. It's math calculation. So this number is 67.5. That makes sense because this number is too much. So this number will be 67.5 times 1.15. I got 77.6. This is the volume of excavated soil in the loose condition. This is the volume that needed to be transported by trucks. Later, we will work on the trucks, how many trucks we need to rent, how many workers, how many excavators. So at this moment, you need to keep in your mind, we have bank cubic yard based on the actual dimensions of your excavation, and we have something called loose cubic yard. After excavation, this is the state of your soil. The last point, it's a piece of cake. Trench excavation. If you would like to excavate trench like this one, it's very easy to figure out the trench volume. Just you need to multiply the length of the trench, this total length, how long, by the average width. If the width is changing, so go ahead and define the average. If this width like this one, okay, we are using one width. But if the width is changing, we are going to use the average. Okay, add the different widths divided by how many of them. Time the average depth. What is the depth of this trench? If you multiply these three dimensions, you can get the volume, and this volume will be in cubic feet. If you divide it by 27, it can be bank cubic yard. If you have the bank cubic yard and you have a swell factor, you can convert it to the loose. Hey guys, keep in your mind, this is a good picture to explain this for you. The soil is still inside this trench is called the bank cubic yard. If the soil is already excavated like this, it will be in loose cubic yard. Does that make sense? Keep in your mind, the volume of the soil inside this trench is smaller than the same soil. after excavation in this state, because we have loose state. That makes sense? So based on the dimensions of your trench, the volume will be bank cubic yard. If you multiply it by 1 plus swell factor, it will be loose cubic yard, which is this state.